Hello everyone. Welcome to this series on computer applications. This series is specially designed for students following the ICSE curriculum prescribed by the CISCE Council, New Delhi. We'll be covering key topics and concepts as outlined in the official syllabus, explained in a simple, practical, and student-friendly way. Now we are going to work on bubble sort process, the logic behind it. We have already done the selection sort process. We will, as we did in the selection sort process, we had actually taken five children who we wanted to arrange in ascending order of their height. So here also we are doing the same, but using the bubble sort process. Now in bubble sort process, we actually compare adjacent cells. In selection sort process, we actually tried to figure out from a particular position which child is the shortest and we swapped at that particular time. Over here, we do not figure out where is the shortest or tallest. We just compare two children who are standing side by side. So we will compare child number 0 and 1. So when we compare 0 and 1, they are not in ascending order because the first one is a taller child. So what we do is we swap them. So swapping is straight away now. It's not that we figure out which is the smallest one. Okay, so that means this is done. We move forward. I'm now standing besides the child number 1 and I now compare child number 1 and 2 and we figure that they are also not in order, so we basically exchange them. Okay, so once this swap is done, we move forward. I'm now standing beside the child number 2 and we find that these two children are not also not in order, so we swap them. Okay, so child number 2 and 3 are also swapped, and now I'm standing beside child number 3. They are also not in order, so we basically exchange them. Okay, we've swapped them. Okay. So after the last swapping is done, then you can see this is the last swapping that needs to be done. I don't need to go and stand beside child number 4 and figure out whether the next child is shorter or smaller because this is the last one. Okay. So that means what we will be doing is we will be comparing the elements number 0 and 1, then 1 and 2, then 2 and 3, and then 3 and 4. And once these four are done, this is called as the first pass. This is pass number 1. And once the pass number 1 is finished, we can figure out that the last child is the tallest child. In fact, you can see that the tallest child has been pushed, swapped again and again and again, and pushed from the beginning to the end of the line. What do we do next? We start again from 0 to 1. It's not that once we have done the pass, then everything is done. So because we still see that everything is not in order. We just know that the number 4 is the tallest. Okay, so we start off from 0 again. Are 0 and compare again 0 and 1. So are they in order? No, they are not in order. So we swap them. Okay, so that's it. Again, I go and stand besides 1 and we see, okay, these are also not in order and we will exchange them. They are exchanged. Okay. I go and stand beside number 2 and figure out, are they in order? Yes, they are in order. So I leave them alone. Okay, there is no swapping there. How many times did I have to compare now? I compared 0 with 1, 1 with 2, and 2 with 3. That means I did only 3 comparisons now in my second pass. And after the second pass has finished, we can figure out that the element number 3 and 4 are the tallest and in order. What do I do next? Bubble sort process. I start off with 0 again. So that means I compare 0 and 1. Are they not in order? No, they are not in order. So I exchange them. All right. What next? I go and stand beside number 1. Are they in order? Yes, they are in order. So there is no problem. We leave it as it is. Now in the third pass, you saw that I have done only two comparisons. That means 0 with 1 and 1 with 2. What next? What next is I have left only with number 1. So I go back to 0 again. I compare 0 with 1 again. And we figure out they are in order. So we leave it alone. Now after this fourth pass is done, in the fourth pass you can see that I had only one comparison to do. That is only 0 with 1. That's it. Okay. you saw that the first pass was actually the largest one, the second pass is smaller, third pass is a little smaller again, and fourth pass is the smallest. Now, the what is the basic logic? The basic logic is every time we compare adjacent cells. All right, this is the logic. Let us do. Let us see a process. Now let us see with numbers. We have already done with children, heights of children. Let us see the process with numbers. In pass 1, as you can see, in pass 1, we are going to compare 0 with 1, and that means 8 is compared with 4. Are they in order? No, they are not in order. So 4 and 8 will come like this, and the rest of the numbers are exactly the same. Not what we do. We are now going to compare 8 with 5. Now 8 with 5 is not also comparing, okay? So what do? Is we bring 5 here and 8 here. So that means we swap them and then we put the rest of the numbers like that only. The next comparison is going to be 8 and 1. So that means this is element number 2 and 3. So 8 and 1 are actually going to become 1 and 8. And this is going to be coming like the numbers are going to be like that. So the right now it is the value of the values are 4, 5, 1, 8, and 2. Now you can imagine the last one is basically going to be a comparison of 8 and 2. So 8 and 2 are actually going to become 2 and 8, and the rest of the three numbers are going to be exactly the same. So now you can see now at the end of the first pass, which was actually four comparisons. So the first comparison was basically these two elements, then comparison of these two elements, then comparison of these two elements, then comparison of these two elements. Okay, and at the end of the first pass, you can see that number 8, which is the largest number, has been pushed from the beginning to the end. You can see it has reached the end now. Now we can leave 8 alone now. We don't need to shift 8. So we basically want to do the comparisons again. So we start off with 0 and 1 again. So are 4 and 5 in order? Yes, they are in order. So we will just, the entire list is going to be copied exactly as it is. Next is 5 and 1. Are they in order? They are not in order. So this becomes 1, this becomes 5, and these two are copied as it is. Next comparison is going to be between 5 and 2. They are not in order, so 2 comes here, 5 comes here, 8 comes here, 1 comes here, 4 comes here. So that means at the end of the second pass, you can figure out now, we actually did a comparison of 4 and 5, then 5 and 1, then 5 and 2, and then at the end, 5 and 8 are now the largest numbers in order, in ascending order, and they are at the end. Now we can leave them alone now. All we need to worry about is arranging 4, 1, and 2. Pass 3 basically will require only two comparisons, that is 4 and 1, and then whatever with 2. Okay, so 4 and 1. Are they in order? No, they are not in order, so we make it 1 and 4. And 2, 5, and 8 are exactly like this. Next comparison is 4 and 2. So 4 and 2 are not in order, so this becomes 2, this becomes 4, and these two numbers come exactly as it is. So now we can figure out in the third pass, which had only two comparisons, that is 4 and 1, which swapped to 1 and 4, then 4 and 2, which swapped to 2 and 4. So after this thing is finished, you can figure out that the last three numbers now are the largest numbers in order now, in ascending order. Now we are not sure about these two. This is the only comparison that is going to happen now. Are they in order? Yes, they are in order. So we just, that comes like this only. So the numbers which were 8, 4, 5, 1, and 2, finally after four passes, you have seen that they have arranged themselves in ascending order. You can see that first pass was 4, second pass was 3 comparisons, third pass is 2 comparisons, last is only 1 comparison. Now, let's figure out the loops that we are going to use here now. Let's see, X I'm going to use as the outer loop. It is going to be a nested loop because we are going to have 4 passes, and in the 4 passes there are going to be many comparisons that are happening there. Okay. Similar to the selection sort process, there also we had a nested loop. Okay, and we'll do a comparison a little later. So x basically is going to have values from 0, 1, 2, and 3. So these are the four possible values of x. Y I am going to use as my inner loop, and inner loop is going to have values from 0, from 0, 1, 2, and 3. So why? Because I am now going to compare 0 with 1 with 2, 2 with 3, 3 with 4. So I hope this makes it very clear. In the second loop, when x is 1, we know that the pass is going to become smaller. So it is going to be 0, 1, and 2 only. Next is going to be 0 and 1 only. And last is only going to be 0. You can see that the inner loop is going to become shorter and shorter and shorter. In the first loop, when x is 0, we started from 0 and went up to 3. Why? Because x was 0, 0 was compared with 1, 1 with 2, 2 with 3, 3 with 4. In the second pass, we had only 0 with 1, 1 with 2, 2 with 3. In the third pass, we had 0 with 1 and 1 and 2. And last pass, we had only 0 with 1. Okay, 0 with 3 is very easy to implement. So if I'm taking x as the outer loop, so I'll say x is equal to 0, x is less than m dot length minus 1, because I just want to go to 3, I don't want to go to 4. So x plus plus. Coincidentally, this loop is exactly the same as the loop that you use for the selection sort. Now, inner loop is, if I take the loop variable as x as y, so y is equal to 0, y is less than m dot length. Where am I going to go up to now? Uh, if I'm always starting with 0, I'm reaching up to 3 in the first loop. So let me just go up to 3. So up to 3 is going to be y is equal to y is less than m dot length minus 1. Now if I just keep it like this only. Okay, I'm going to change this in a little while. Uh, so the inner loop is going to go from 0 to 3. Outer it is going from 0 to 3. Okay. Now if I change, if I now check now whether the left element, that is my, the element that we are on at the moment, is greater than, so that means the child is taller than the next child. The next child is going to be my plus 1. So if it is taller, then what do? We swap them. So swapping is done using a temporary variable. So I'll say t is equal to my, and my is equal to my plus 1, and my plus 1 is equal to t. So this is the sort process. We close the loop, close the if, close the inner loop, close the outer loop. So this is a very simple kind of a loop that we have for the bubble sort process. Now, as I said, I am going to change this in a little while. So if I don't change this, what is going to happen? So when x is 0, this y will go from 0 to 3. When x is 1, it goes from 0 to 3. When x is 2, it goes from 0 to 3. So am I going to have this 3 and 2 and 3 here? I'm not going to have these. I don't need that. Okay. So I want the inner loop to become shorter and shorter. Now, coincidentally, we can actually use the value of x to actually limit the end of the inner loop. So what we can do is, if I put a minus x over here, what is going to happen is, the larger is the value of x, the shorter is the inner loop going to be, because I'm writing a minus x over there. So if it is a minus 1 or a minus 2 or a minus 3, don't you think this inner loop is going to become shorter and shorter and shorter? It is always going to start with a 0, but it is going to become shorter and shorter and shorter every time. Let us now compare the two processes, the sort process and the bubble sort process. As I told you earlier that the outer loops are exactly the same, so outer loops are exactly the same. All right, so we start from 0, go up to 3 if there are 5 elements in the array. Now the inner loops are different. Now inner loop in the selection sort process, we basically try to figure out which is the smallest element starting from position x. So we start always y with x, it goes up to the end. All right. Over here, we actually doing the comparisons of adjacent elements. So their adjacent elements start with 0, 0 with 1, 1 with 2, 2 with 3, 3 with 4. So that means we are always starting with a 0. Over here, we are always starting with an x. And in between the two loops, we need to store the initial value of the low and the pos. So in this loop, we do not need anything because we are just comparing adjacent cells, so we don't need to worry about that. The swapping in selection sort happens after the inner loop has finished. Basically, after it has figured out where is the smallest element, and if the smallest element is not at the same position as where we started from, we actually swap them. All right. So swapping doesn't happen so often in selection sort. But over here, it is going to swap every time one element is greater than the second element. So the swapping happens inside the inner for loop. Here it is after the inner for loop. So this is the basic difference. There are too many swaps happening in the bubble sort. Yes, why? Because it is actually happening inside the inner loop. So there are many swaps happening. In the selection sort, there are not many swaps happening. So it basically goes through the loop, figures out which is the smallest element, where is the smallest element, and then it actually performs the swap. So this is the basic difference between the selection and the bubble sort. Let us write the code for this for bubble sort. So we have created a class called bubble sort in which we have written the main function. I started with the creating the array with with some values. In your board exam or your semester exams, you will be given these values. Okay, so don't worry about inputting. So normally you can input also, but I'm taking the values. I've taken two variables x and y. I'm going to use them for my loops. Uh, I have created two for loops. One is here, which is actually displaying the array before the bubble sort happens, and this is after the bubble sort happens. Both the loops are exactly the same, but the arrays are not the same, are not going to be the same. I'll start my bubble sort process here now. So that means this is the point where the bubble sort process starts. All right. Okay, so this process has finished. Let me just compile it and let me run the main function. And you can see that it displays the original array before the loops, before the bubble sort, and this is the ascending order array in ascending order after the loop bubble sort finishes. Now, everyone, I would want to see um, this process in every pass, okay, or during every pass. So what I'll do is I'll just make a copy of this and put it inside the for loop, inside the loop inside there, and create another variable because I cannot use x because x is being used in this nested for. So I'll use z over here. So z plus plus, and I'll display an mz here now. Okay, okay. Let us see how things happen now. See, uh, it has started the first pass. 9-3 is being compared. When 9-3 is compared, they are not in ascending order, so they make it an ascending order. Again, 8 and 9 are being compared. They are made in ascending order. Then 9-4 are being compared. 4-9 is again swapped. 9-1, 9-1, 1-9 is swapped. Okay, so this is the first pass has finished. What do we do next? Then we started off with 3-8. 3-8 is not a problem at all. They are already in ascending order. This array remains the same. Now next comparison is 8 and 4. 8 and 4 is being compared, so they are not in ascending order. So 4-8 they swap. 8 and 1 they are also swapped. So the swapping happens here. Alright. This is at the end of the second pass. Now we start off with the comparisons again. With 3 and 4 are exactly okay, so they are okay. Next we compare 4 and 1. After 4 and 1, after the swapping of this thing happens, it becomes 1 and 4. So after that nothing happens. Okay, now lastly only 3 and 1 is to be checked. So 3 and 1 is swapped. So 1 3 4 8 9 is the at the end of the fourth pass. And this is after the array the bubble sorting has happened. In fact, the first line and the last line is not inside that for loop at all, so you can figure that out. Okay. Now you have seen the dry run also of this program. All right, and in your actual programs, you will not be writing this code at all unless you are required to. Okay, so this part of the code you can leave it, but you will normally display the array before the sorting happens and after the sorting happens. You probably should be displaying some message over here, and you can say you can display a message here that this is after sorting. Okay, and before the previous loop over here you would probably display before. Okay, so let's just run this program again and see. So before sorting is this particular line, and after sorting is this particular line, and these are all the passes that are happening inside the bubble sort. I hope this is bubble sorting is very clear to you, and the comparison between the two is clear to you. Thank you for watching. I'll see you in the next video.